All right, hey everybody, this is 10.1. We are covering angles and triangle basics. So you've covered this type of information before, especially like vertical angles, alternate interior angles, but it's probably been a while and it will help us as we go to the next couple lessons, okay? So this will be helpful. If you have any questions as we go along, just stop by and we can talk, all right? So, all of these types of angles that we're talking about are angles that are made by parallel lines. So parallel. So this line and this line are parallel lines. A lot in your homework and maybe on our test, you might see these symbols like these little triangles. That's saying that they're parallel. Sometimes you'll have them written like this as well. Same sort of thing. So it's just telling you which lines are parallel. Okay, so we have two parallel lines, and then it's cut by a transversal. So this line is a transversal. And when we have those types of like parallel lines and a transversal, then we have some information that we can know about some of the angles. So first off, let's talk about vertical angles. So vertical angles are angles that are like kitty corner or diagonally from each other. So for example, 1 and 3, I want to do a different color, I want to do green. Okay, 1 and 3, those are vertical angles. Okay, we could also have used 2 and 4, 3 and 7, or 6 and 8. But just to keep it simplified for yourself, for your notes, I would only just circle one pair. Okay, so those are vertical angles. What do we know about them? Well, if you look at them, they look to be the same, and they are. So vertical angles are congruent, meaning that they're the same. Okay, same value. All right, so keep that in mind as we go along. Next is alternate interior angles. So alternate meaning not the same side. They're on opposite side of the transversal, okay? So like opposite from these, those are on opposite sides. So alternate, and then interior, meaning inside the parallel lines. So 4 and 6, those are alternate interior angles. And they are also congruent. Okay, 3 and 5 is those are also alternate interior angles. Okay. Next, and we won't use this one a whole lot, but if you really want to, I think there's a couple in the homework where you could use these, but often I use alternate interior angles and vertical angles, and maybe one of the others on the other below that we haven't covered, but this one's also good. Alternate exterior, so alternate meaning not the same side, and outside of the parallel lines, exterior. Okay, so these are also congruent. All right, next is corresponding angles. This one's not, I don't think, is as descriptive, like to be able to like know what it is already, but corresponding angles are like 1 and 5. Okay, so those are also congruent. Okay, next is adjacent angles. You'll probably use that quite a bit today. So adjacent angles, adjacent meaning next to. So like 1 and 2, those would be adjacent angles. 1 and 4 would be adjacent angles. So these two would be adjacent angles. Or we could do 4 and 3, or 6 and 7. So those are all adjacent angles. And what should we know about those angles? Well, they're not congruent. They're not the same. If you look at these two angles, this angle is a lot smaller than this angle. Okay, but what we do know is that the angles add to 180. Okay, 180 degrees. All right, and then the last one is same side. So they're like all on one side of that transversal, and it's interior. So like 4 and 5, those would be same side interior angles. And what should we know about that? Well, these aren't congruent. Again, this looks much bigger angle than this. But we do know that they are supplementary, that they will add to 180 degrees. Okay? All right, so keep that in mind as you go through your homework. It'll be helpful. Okay, so in class we went over this. You're asked to find all of the missing angles. So like this angle, this angle, this angle, this angle. So lots of angles, all of these angles. We're trying to find all of them. Okay, and I just made a mess. Okay, one thing it tells you in the notes and instruction is that line A is parallel to line C. So that's going to be important when we're trying to find all of the angles. We can get a lot without knowing that, but at a certain point we would have to know that those two lines are parallel. Okay, so let's kind of go through this and see if we can figure out some of these angles. It'd be great if you pause and do your best and then go over this would be a good idea. All right, so I always like to find vertical angles. Those are really easy to find. So vertical angles would be, here would be 100 degrees and here would be 30 degrees. Okay, they're always just the angles that are like diagonal. Okay, we can also find the adjacent angles really easy. They're the angles that are next to these angles. So what makes this, or I guess we should say, what is this angle? Well, we know that these angles together, I guess this angle and this angle, have to give us 180 degrees. So this one would have to be 80. Okay, and then again we can do the vertical angles to find this 80. And then this other one by the 30, so I want to figure out what this angle is. Well, it's also an adjacent angle. It's adjacent to the 30. So that and the 30 should give us 180. So this should be 150. And then this would be a vertical angle as well. So the thing is that there's lots of, I mean, you could have done adjacent angle for all of these. You wouldn't even have to use vertical angles, although sometimes that will be beneficial as we go along. Okay, so here is something that we haven't covered yet. How can we figure out what this angle is? And we haven't talked about triangles yet. So triangles, if we add the angles of a triangle, what do we get? So if we add all the angles of a triangle, we get 180 degrees. So the angles of a triangle add up to 180. Okay, so we can use that to find this missing angle. So the angle of a triangle is 180, but part of this triangle we already know the 80 and the 30. So we could subtract 80 and subtract 30, and that would give us 70. So this angle has to be 70 degrees. Okay, again, the angles of a triangle have to add up to 180. So 180 minus the 2 that we already know, that should leave us with the angle we don't know. Alright, so now we could figure out maybe the adjacent angle. So if we wanted to figure out what this angle is, again, adjacent angles add to 180, so this has to be 110. This is a vertical angle, so it's also 110. And this is also a vertical angle for the 70, so this is also 70. Okay, so now we're just missing the angles that are down here. And the only way we can get to those is by what we know about parallel lines in a transversal. So if we look at, I don't know, maybe let's look at this angle. Is there a way that we could figure out this angle? Well, considering that we have two parallel lines and a line that is a transversal, then that means that we know that this, if you can see where I'm marking, that's kind of the hard thing is this 30, is that those are alternate interior angles. So that means that this angle in the bottom also has to be a 30 degree. Okay? And for the same reason, we could say that this is 150 because this and this, those are alternate interior angles. Okay? Or you could just do adjacent angles and that would give you the 150. Okay, so this is also 30, this is also 150. And then we'll do the same sort of thing that we did just barely for these angles. So again, we have alternate interior angles. So this is the same as this angle. So this is 80. Okay, and then this angle is the same as this angle, which is 100. Okay, so those are alternate interior angles, this one and this one. Okay, and then we could do vertical angles if you wanted to find our other angles. Okay, I know it's a little trickier when I'm not you can't see what I'm pointing at, but if you have any questions, please just let me know. Okay, all right, there are two others examples I think will be helpful. Okay, so here in class, I asked students, well, it says here, first we make sure that these two lines are parallel. It says that right here. So BE is parallel to FI. Okay, also is mentioned right here. So these symbols, again, those are saying that they're parallel. All right, and they want to know what is x? What is the value of x? And it says to explain how you know. So, I mean, I don't think that you might maybe not need to write it so much, but just being able to explain why angles are the same, they're congruent, and why they add up to 180. So, if we want to find x, this is one way one student showed me today, is that these are vertical angles. So this would be 48. And then I'll use a different color. This angle that I'm marking as green is the same as this angle. These are corresponding angles. Okay, so this is also 77. And then we know that the angles of a triangle add to 180. So 180 minus 48 minus 77 would give us 55. Okay. Another student in a class showed me that you could also do this angle and this angle are also alternate interior angles. So this would be 48, and then they use this angle and this angle to find x. So it kind of saves a step. So again, there's lots of different ways to do it. Both are great. Okay, I guess I'll leave that there. Okay, and then the last example, this one talks about these two, like these symbols on these triangles. Like, what does these two, maybe I probably should have used a different color. So these two red symbols, what does that mean for a triangle or for sides? Okay, so this basically says that we have two congruent sides. Okay, so these is a special type of triangle. It's called an isosceles, and I'm not sure if I spelt that right, but that's okay. All right, so with isosceles triangles, there's something special about those. if we have an isosceles, I'm going to rewrite it here. This would be helpful if you write this down on your notes too. If you have two congruent sides, it means that we have two congruent angles that are opposite of those congruent sides. Okay, so that basically means that this angle and this angle are the same. Okay, we're going to use that in just a little bit. I think I got a little ahead here, but it's going to be okay. All right, so the first thing asks, what do you know about the angles of angle, maybe I should put an angle symbol here, angle CAB. Okay, so CAB is basically this, the middle letter is like the vertex of your angle, and then the C and the B are telling us like what direction are we doing it, okay? If that makes any sense. Let me show you another example in a second, but we're basically saying angle CAB, so this angle, how is that related to angle NAB? Okay, so what do you notice about those two angles? Well, they're the same, they're congruent, okay? Okay, basically those two angles, if we had like a small triangle and we had a big triangle, that, and this would be NAM, this angle, and then we did CAB, and we wanted to know this angle. Well, those two angles are congruent, okay? These are congruent. That's the symbol we use for congruency. So it's like equal with a little thing on top, okay? So congruent. These types of angles, it has a special name. These are called reflexive angles, okay? It's kind of nice to know, but again, you won't be tested on that. But if you have an angle inside of an angle, those are going to be congruent angles. Okay, that's the thing that you really need to make sure you get. All right, so find the measure. Next thing is find the measure of NMA. So N, I should get a highlighter. Let me get a highlighter really quick. I have one right here. So NMA. So we're looking at this angle. And that would give us, well, how do we know what that one is? Well, these are corresponding angles, so this is also 75. Okay, so this is 75 degrees. And then it says, what is the angle of, let me use a different color here, for angle MNA. So this is the other angle that we're trying to find. Okay, so this angle now. And because it's an isosceles triangle, we also know that this is 75. And then from there we can find what the measure of A is. So angle A would have to be 180 minus 75 minus 75, which would give us, I think, 30 degrees. Okay, all right. The last thing we're going to be talking about is called the mid-segment theorem. Okay, well, let's first talk about what a mid-segment is, or what a midpoint is. Okay, so if we were to, let's say you started with a blank triangle. I'm just going to do it right here. If we had a triangle, a midpoint is a point that's halfway between like the vertices of the triangle. So if this was A and B, the midpoint would be halfway between. And then if we took a midpoint for maybe A and C, which would be right here, if we drew a line between those 2 points, that's called a mid-segment. Okay, and we can kind of see it down here. One thing we notice is that if it's a midpoint, then both sides, like the two sides beside, I guess what I'm trying to say is we basically cut that ML into two equal parts. Okay, so this length is the same as this length. Okay, makes sense because it's the middle. And the same thing applies to point 0 or O is halfway between M and N, so that means that MO, this, is the same length as this. Okay, so there is some sort of relationship whenever we have a mid-segment. One way we can kind of look at this is by maybe putting in some like random numbers here. Like say maybe this is 4. If this length is 4, what would be the length of the larger triangle? Because you kind of see here we have like a small triangle inside. This would be, let me use my pen, this is like a small triangle. And then here, if we, let me try red, this would be a big triangle. Okay, so it's kind of like a triangle inside of a triangle. Anyway, so if that small triangle length is 4, this would have to be 8, right? Because this is 4 and 4 plus 4 is 8. Okay, if this was maybe 6, this length was 6, what would the long side of the long triangle side would have to be? Well, this would have to be 12. Okay, so and this is the same for all of the sides of the triangles. So if this was 5, what would this have to be? Well, this would have to be 10. So this is basically the theorem, is that 2 times the small triangle is equal to the big triangle. And maybe I should add here side. Okay, so if we take the small side of the triangle, or the small triangle's side, and multiply it by 2, we'll end up getting the big side of the triangle. Okay, so let's see if that makes any sense. I don't know if I explained that super well, but if this is 10, what would this have to be? Well, this would have to be 5, because 5 times 2 would give us 10. All right, what about B? If this is 9, what does X have to be? Well, that would have to be 18. Okay, so we're basically just taking the smaller triangle's side and multiplying it by 2, and that gives us the side of the bigger triangle. Because again, the triangle is just being, all of its sides are just being doubled. Okay? Alright, this is more like what you're going to see on like your review and your test. Is something like this. These ones are like so simple. It just asks you to do a little extra algebra. Alright, so but it's the same process. This is our small triangle. And again, I'm going to kind of show this to you. It's kind of cool. If I take that and copy it, and I paste it, and I put one here, and I put another one, and I put it here, what do you notice? Well, 2 of the small triangle gives us the big triangle side. Okay, so again, you kind of see that visually, but we're going to take 2 of the small, and it's got to be equal to the big triangle. And then we just need to solve for x. So the first thing we want to make sure we do is get rid of our parentheses by using the distributive property. So 2 times x is 2x, and 2 times 2 is 4. And then we still have this on the other side. Okay. And then we'll want to get x by itself. So you can, as long as you follow like the rules of like doing things to both sides, it should be great. But the easiest way, I think, is if you can always kind of focus on keeping things positive if possible. So you could subtract 2x to both sides, but then you're going to end up getting a negative x. And I feel like that just makes it harder. So always keep the bigger and subtract the smaller. So let's subtract x from both sides. So we'll get x plus 4 equals 11. And then we'll keep the 11 and we'll subtract the 4. So x equals 7. Okay? And on your homework, some of them will just ask you for x. You'll also have ones that will say, well, let's find the length of the triangle. So find the side QS. So to find that, we would need to plug that x in for 7, or 7 in for the x, and we would end up getting 11 plus 7 gives us 18. I would also recommend that you would plug it into the other expression and make sure that it is doubled. So 7 plus 2 gives us 9. So 9 times 2 does give us 18. That's a really easy way to make sure that you did your algebra correctly. And if you got it off somehow, then it wouldn't double from the small to the big. Okay? I'm going to do one more example. If you feel like you're good, you can just skip this. But we will also look at the homework really quick because I made a couple mistakes. Sorry. Okay? So again, we're going to do 2 times this is equal to the bigger side. So 2 times 2 would give us 4x, and 2 times negative 5 is negative 10, is equal to x plus 11. Again, keep the bigger, subtract the smaller, so it would subtract an x, get 3x. And I also like to kind of like add the 10 to both sides at the same time, just to save some space. And then we would divide both sides by 3. So what do you know? X is 7 again, but don't think it's always going to be 7. And they want us to know, what is TU? Well, that's the smaller triangle. So we would do 2 times 7 minus 5. So 14 minus 5 is 9. And again, it's not helpful, or it's not difficult to plug it in here as well. We would get 7 plus 11 gives us 18. And again, it doubles. Again, it's not always going to be 9 and 18, but there you go. Okay? All right, so let's go look at your homework really quick because Mr. Warner made a couple mistakes. So on your homework, it doesn't show these 2 numbers. Okay? So you're going to need to write those into your homework. Okay? One thing, just again, a reminder is this is where you're going to put your answers. So angle MGF, so I'm going to get into this highlighter, MGF, so we're trying to find this angle, and that's what we would write down over here. Okay, so just being able to read what they're saying, like the angle BGF, start with B, go to G, then to F, that makes the angle that we're looking for. Okay? So like the next one, just again, one more, or actually let's do the last one. EFG, so EFG, this is the angle for this example. Okay? All right, and then that's all good, that's all good. For 5, we did this example together in class. I'd like to see if you can do it on your own, but if you have issues, I'll go back to that at the very end. Okay. There weren't any issues with these ones. There was a mistake with 12, so I fixed it here if you want to fix it there. But basically, what they want to know is what is the length PQ. So that's this. Okay. And then they say that N and P are midpoints, so this is a mid-segment. So that will helpful. It's very similar to, I guess we should say, 6 and 7. Okay. Same with 13. This is a midpoint, mid-segment, and they want us to know how long that is. Okay. So see if you can get those figured out. All right. So I'll go over that one example if you want for 5. Okay, so we are trying to find x, and this is the only information that we have, is this angle is 112. So basically what we're going to want to do is we're going to work our way and find all of these angles until we can get to x. This is called angle chasing. Okay, so if we have that angle, can we figure out what this angle is? Well, those are adjacent angles. They have to add to 180. So this has got to be 68, because 68 plus 112 is 180. Okay, and then we kind of talked about these symbols. Those are isosceles, which means that the angles that are across from those sides are congruent. So this is 68. And then we know that the angles add up to 180. So this has got to be, if you like do 180 minus 68 minus 68. If I remember, should be 44. Okay? This is a vertical angle, so this is 44 as well. This is an isosceles, which means that this is also 44. And then this has to be 180 minus 44 minus 44, which I think gives you 92, which means this has to be 180 minus 92, which gives us 88. No, wait, yes, 88. Okay, so 88 is what x has to be. Okay, it's kind of like, I don't know, it's kind of like a little puzzle. Some of the students say it kind of like is like Sudoku. Okay, if that's helpful, great. If not, come and talk to me. Oh yeah, and the last thing we didn't talk about is 14. So this is just kind of a bonus. It's really just for fun. If you want to do it, great. If you think it's fun, do it. If you think it's not, then don't worry about it, okay? But this is kind of your key, is that these angles add to 540, okay? So you should be able to figure out what one of the angles would have to be, and then from there you can find everything else. All right, we'll see you later.